All right. Well, here's another example on how to find extreme values of a function on the interval and finding out where they occur. Well, here is an example of a trig function. And once again, when we're trying to find extreme values, we're trying to find max and mins. Okay, so we're trying to find max and mins. Now, in order to find these max and mins, we want to try to identify whether we can use the extreme value theorem. Okay, extreme value theorem, because that makes it very easy. The extreme value theorem can only be used if we have a continuous function on a closed interval. Okay, closed interval. What we have is a continuous function, because sine is continuous, and we have a closed interval from 0 to 7 pi over 4. Okay, that's cool. So what we can do is we can use the extreme value theorem. So what that means is that we are guaranteed, all right, we are guaranteed an absolute max and minimum. Okay, max and min. All right, so we're guaranteed that. And what we can do is, in order to identify the absolute max and mins, we know they occur at endpoints and critical points. Endpoints are at the end and critical points are in the interior. So first we need to test the endpoints. So we're going to take, in order to test the endpoints, simply we're just going to find the value. Because since we can use the extreme value theorem, we know that there is absolutely a max and min, and since we know it only can occur at endpoints and at critical points, it's the only places that extreme values can occur. All right. What we can do is we can actually just find the values at these different points and compare them and find out which is the largest, which is the smallest. Okay, so I'm going to actually plug in our endpoints. So we have f of 0. So we're going to take sine of pi over 4. Now, sine of pi over 4, you should know that it's going to be the square root of 2 over 2. Okay, that's the root of 2 over 2. We're then going to take and find our next one. I'll move this down a little bit. Right there. So now we're going to take f of 7 pi over 4. And when we have this, sine of 7 pi over 4 plus pi over 4. And that's going to give us 8 pi over 4. 8 pi over 4, which then gives us sine of 2 pi. Sine of 2 pi, sine of y, cosine x, that's what I say. The y value is going to be at 2 pi, 0. So we have two values of pi over square root of 2 over 2 and 0. So if this were, we don't have any critical points, this would be our absolute max and this would be our min. Okay, so this would be a max and this is a min for now. However, we do now need to test other critical points. So we don't know this for a fact, but I'm just putting that right there. Now, the next thing we're going to do is we're going to find our critical points. To find the critical points, once again, it's important that you understand that critical points are located when f prime equals 0 and when f prime does not exist, say where it's undefined. So in order to figure this out, we're going to take our function, which is sine of x plus pi over 4, and we're going to find its derivative. So the derivative of sine is going to be cosine of x plus pi over 4. And the derivative using the chain rule, derivative of the inside is 1, so that is our derivative. Now, where does this equal 0? Okay, so where does that equal 0? In order to figure this out, so cosine, we know that cosine equals 0, and cosine equals 0, if you do our little unit circle here, okay, cosine equals 0, and cosine is x, so it's going to be up here at 0, 1. All right, so it's going to be pi over 2. We also know cosine equals 0 at 3 pi over 2, and 3 pi over 2. So that's going to be 0, negative 1 for our point in our unit circle. So the inside here, if we can get pi over 2 or 3 pi over 2, that's going to be equal to 0. So we're going to set this equal, solve this, pi over 2. All right, and we're going to solve it. X is equal, then we have to find a common denominator, so we have 2 pi over 4 minus pi over 4. And what we then get is pi over 4. So when x equals pi over 4, it's going to be 1. And we're also going to go and find out what happens when it's going to equal 3 pi over 4. I believe that's in our interval. 7 pi over 4 is in the fourth quadrant, so yes, that would be. All right. equal 3 pi over 2. Subtract that again, so we're going to have 2 be 6 pi over 4 minus pi over 4. Excuse me. A little sneeze there. 5 pi over 4. All right, that equals x. And so we have these two different values. So these are two critical points. All right. So since they are in an interval, we need to test out these critical points. All right. So I'm going to just take these and bring them up here. So we can use this. Yeah, come on. Come with me. All right. And bring the power of 4. So that's one of our critical points. We can take our other critical point and bring it right there. So I can see it all. So when we have this, now we're going to test these two. By testing them, we're going to plug them into the original function to find out what the value is going to be. All right, and we'll get rid of this, put that down there. All right, so we have a little extra room. So now we're going to take these values and we're going to plug them in. So we're going to find out what is f of pi over 4. So we're going to actually plug this into the original function. And when we have this, we're going to have sine of pi over 4 plus pi over 4. Pi over 4 plus pi over 4 is pi. It's going to be 2 pi over 4, which is pi over 2. And the sine of pi over 2, okay, is going to equal 1. It's going to equal 1. We can go over here and plug in 5 pi over 4 in there. And then what we have is sine of pi over, or 5 pi over 4 plus pi over 4 is going to give us sine of 6 pi over 4, which is 3 pi over 2, which is going to equal negative 1. Negative 1. So once we find all of our different values, all our different options, and I'm going to erase this because this is what it was if we didn't test our critical points. So make sure you test your critical points also, because we did realize our answer changed. Looking at all of our values, we realize that all right, our highest value in this case happens to be located at pi over 4. So our absolute max is going to be here. Okay, it's going to be here at pi over 4. So this is an absolute max. Our absolute min is going to be located here at our critical point, all right, at negative, or 5 pi over 4, which is at negative 1. These other values might be relative min or maxes, but we are just trying to identify our absolutes. And so what we have right there is f of pi over 4 is 1, f of 5 pi over 4 is negative 1, and that is what we have for our relative min and maxes. Okay, so I hope this helps out in how we can solve these different problems, and hopefully this makes sense to you in solving this. And yeah, so that's what we have, and I guess good luck and God bless in your future problems.